This is Earth's meteorological safe zone, between 5 degrees north and south, historically off-limits to tropical cyclones. The reason is the Coriolis effect. This planetary spin whips storms into rotation, but at the equator, the force is non-existent, leaving the air too still to spin. This geographical reality turned specific regions, like the narrow Strait of Malacca, into reliable sanctuaries. Communities here built their infrastructure around the scientific certainty that a major cyclonic event was physically impossible. On November 22, 2025, that certainty was completely shattered. Regional monitors began tracking a tight, rapid, low-pressure rotation, developing directly inside the strait, well south of the 5-degree line. This was Cyclonic Storm Senyar. It wasn't a record-breaker for its wind speeds, but its presence alone was a shock.
Over the following days, it claimed over 1,500 lives and caused nearly $20 billion in damage across Indonesia, Thailand, and Malaysia. Senyar proved that the calm waters of the equator are no longer a shield. It suggests that as the climate shifts, the safe zones we've relied on for centuries are being redrawn by forces our current models didn't see coming. If the Coriolis force is absent at the equator, how did Senyar manage to generate its rotation? The Northeast Monsoon pushed down from southern China, slamming into a warm equatorial crossflow from the southwest. As these winds collided, the coastlines of Sumatra and the Malay Peninsula acted as a physical funnel, squeezing the air into a horizontally rotating storm. Once the storm formed, it broke another rule. Most storms in this region drift west into the open ocean, but Senyar took a path never before recorded. It moved east. After forming, the storm made landfall on northeastern Sumatra. Blocked by wind shear, it hugged the rugged coastline at a sluggish pace. Then, in a maneuver rarely seen, it performed a tight U-turn, migrating back off the coast and re-entering the Strait of Malacca. Re-energized by the water, Senyar crossed the strait and made a second landfall over peninsular Malaysia, grinding its way across the central mountains before finally spilling out into the South China Sea. This combination of topographical traps and extreme oceanic heat bypassed the traditional laws of physics, turning a narrow shipping channel into a corridor of unprecedented destruction. To understand why a storm with relatively weak winds became so lethal, we have to look at how that massive volume of rain interacted with the terrain. This is orographic lifting. As Senyar's moisture-heavy clouds were pushed against the steep Bukit Barisan Mountains, the air was forced upward and cooled rapidly. This squeezed out nearly 400 millimeters of rain, about 16 inches, in less than 24 hours. This deluge hit a landscape that was already on the edge. In Sumatra and southern Thailand, the rain fell onto steep, high-altitude terrain that has been drastically altered by human activity. Over several decades, millions of acres of biodiverse natural forest were converted into monoculture palm oil and rubber plantations. These crops lack the deep, complex root systems needed to anchor the soil and absorb water. Without that hydrological sponge, the rain doesn't soak in. It transforms into high-velocity surface runoff, turning hillsides into viscous mudslides that tear down slopes. This runoff swept away entire villages, killing over 1,500 people. It also devastated the Batang Toru ecosystem, the only home of the critically endangered Tapanuli orangutan, as flash floods carved new river channels through the plains. The storm provided the water, but human land conversion provided the conditions for a massacre. Senyar was a lethal reminder that when we strip the land of its natural protection, we weaponize the weather. The reality of the post-Senyar world is that we can no longer rely on geographical safety. Warming oceans and land degradation have turned once stable regions into potential disaster zones. Survival starts with updating our science. Regional weather agencies must adjust their algorithms to recognize that powerful monsoon surges can now trigger cyclonic rotations even at the equator. Governments must also immediately prioritize the full restoration of natural sponges. This means halting the clearing of steep slopes for plantations and replanting both upland forests and coastal mangroves to buffer against future deluges. Finally, regional alerts must be paired with local early warning networks. In remote areas, communities need clear, mapped-out evacuation routes to high ground that are tailored to the specific risks of their terrain.
Cyclone Senyar was a warning from a changing future. It showed us that impossible weather is the new reality, and surviving it will absolutely require us to fundamentally rethink how we live on and how we protect the land.